All right, this week's lab is thin lenses. We're going to explore how to form images using curved glass, so by way of refraction. And so the first thing that you're going to see when you go through the handout is some of the background theory for how we can get images to form using either converging or diverging lenses, sometimes referred to as biconvex or biconcave lenses. You'll notice the thin lens equation is provided, the way we can quantify where an image will form based on an object distance and a focal length for the lens. You'll notice in the handout we are using P for the object distance and Q for the image distance, as opposed to D sub O and D sub I for object and image distance like in the textbook. And so moving along, we see the definition for magnification, the ratio of the image distance to the object distance, with the negative sign there telling us about whether the image is inverted or upright. And then we get through the background and we end up needing to launch a simulation for geometric optics. And so when we do that, we land at a site that is a Flash-based site. So you may need to download Flash if you're on a computer that doesn't have Flash installed. If you're using the computer that you've completed the previous labs on, then you've already installed Flash because we had Flash labs in past weeks. And so you may have Flash installed, but you just need to perhaps click to activate, give permission for Flash to load. And when you do that, you end up with this screen. And so this screen, you end up with this toolbar up at the top where you can control the rays that are shown coming from the object. The object is over here on the left. This pencil is our object. And you can grab the object and move it around, bring it off the optical axis. On the right-hand side, that would make this the image. You can adjust the radius of curvature of the lens. You can see what's happening to the x's there, the focal points for the lens as I'm adjusting the radius of curvature. You can adjust the diameter of the lens, how large or small the lens is. And then you can also adjust the refractive index, which of course will also change how the rays bend. You can add a screen as opposed to just viewing the object in the image. You can show guides. You can add a ruler, which we're going to use later on. And so you've got a whole host of options that you can choose from. And as you work through the handout, you'll be instructed on a variety of different actions and experiments to investigate as you make your way through the lab. And so as you work through exercise number 2, you're going to be filling out a table where you're going to be comparing object distance, image distance, focal length, and then categorizing whether the image is real or virtual, upright or inverted, and then investigating whether or not there's a magnification or if the image is reduced. And so working your way through those exercises, you'll make it to part 2, where we're going to investigate compound lens setups. And so we're going to launch this simulation. And this is not terribly surprising. You may, when you launch this website, be met with a screen that looks like nothing is going on. And so I'm glad this happened while we were doing the demo. And so if this happens to you, what you want to do is you want to come up here and delete the simulator from the URL, and that'll take you to the main page for this simulation. And you can choose from here, Start Application, that's where we ran into trouble, or you can use the old version. And if you see here, the old version doesn't look any different, except now we've got, up in this top left corner, you can see there's a bunch of different options. And so the toolbar here is slightly different in appearance to the updated version, but the functionality is exactly the same. And so I'm going to work through a couple of the exercises in the old version, but the new version works the exact same way. You can see up in the toolbar you can choose from single ray, beam, extended ray, rays, point source. None of those things actually do anything until you come down here and click on the open free space. And so what you want to do first is you want to throw down a grid, and you want to snap to grid. So whatever you add to the grid is going to go to the grid points. And the first thing before you get started is you want to add a ruler. And so I'm going to drag a ruler all the way across, and depending on your screen size, you'll be able to get a longer or shorter ruler depending on your computer. But here I've got my ruler laid down, and so now I'm ready to begin following the instructions for the various exercises. So I've just done the first few things here, and I'm going to add a lens. That's the first thing that's in the instructions, and so I'm just going to click and drag, and you'll notice that you can lengthen or shorten the height of the lens, and here I'm going to pick the height so that that white dot there lines up on the optical axis. And so if I want to add a light source, I'm going to click a point source, and again, nothing shows up until I actually click on the space, and now all of a sudden there's a point source. And so once you add that light source, you can move the light source around. So let's get rid of the light source and go back to the lens. You can change the focal length of the lens just by entering different values. So now let's see if I add my point source and then click on the lens. Let's change this to 500. Notice how that changes the image that forms. And so I can click back on the lens and I can change this to, I don't know, minus 50. If you use a minus sign for the focal length, notice how the arrows switched, and now the arrows are pointing in towards the lens as opposed to out. When you use a negative focal length, you're telling the software that you want the lens to be a diverging lens. And so now you'll notice that the rays don't bend towards the optical axis after passing through the lens. They bend away, so they diverge away from the optical axis. One thing that can be useful when you have these rays diverging is it can be useful to see where those rays appear to come from. And so you can click on extended rays, and those orange rays are the rays that are traced back. So if you're over here on the right as an observer and you're looking through, it'll appear that those rays are coming from this spot right here. So those orange rays are the way to trace back and see where those rays appear to be coming from. Looking back at the handout, right, there's a few different exercises that you're going to be asked to complete. You're going to be adding lenses on the screen, and then you're going to move into a more advanced optical instrument with a compound lens. So you're going to have multiple lenses adding to your optical axis. So let's just switch this back to 200. Let's get rid of our extended rays. Oops. So I've got a point source, and what I'm going to do is I am going to add a second lens right here, and I'm going to change that focal length to 50 or 500. Why not? Let's live a little. And so when you have a, and I can move this around to change the location. I can again change the focal length of that lens and I can change the original object distance and the separation between the lenses. I can change all of those different things. All right, so as you move through exercise 5, you're going to be investigating these two converging lenses. And then in part 3, you're going to swap out one of the converging lenses for a diverging lens, which again can be done just by changing the focal length to a negative value. Again, you can use extended rays to see those rays traced back to find where the rays appear to come from. You can get rid of the extended rays just by clicking back on the rays. So you're going to be asked to find the focal length of one of your lenses and then compare to using the thin lens equation to what you know the lens focal length is, because you picked it in the software. And so you're going to be measuring distances, and then you're going to use the thin lens equation to verify that the focal length you get from the thin lens equation is consistent with the focal length set in the software in the simulation. And that sort of rounds out the thin lens lab. Have fun.